All right, so this is using query for November 16, 2020. And I think today, I think we want to talk a little bit about our call for data sets in the wilds that are currently stored in places like GitHub, repos, or other places that might not be optimal for storing data sets. We talk about query being kind of a place where data is a first-class citizen, where it's has custom-made tooling that makes it a great place to store data sets. So Chris on the call put a little call out for folks to share data sets that they see out living in the wild that might benefit from being stored in query. So I think Chris is going to talk a little bit about maybe the city bike data set, maybe among some others. And then I'm happy to talk a little bit about the data story I wrote if that makes sense to fill up some of the time. But I think the focus is on those data sets in the wild that need better homes.
Sure. So yeah, I guess it's not. It's actually not one that made the list on Twitter last Friday. So I've asked the same question, but I think basically searching for data sets stored in GitHub is just kind of a teaser to help us figure out, there's obviously a reason people are putting these data sets on GitHub, and if we can give them a home that makes the data a little more accessible than it would be on GitHub. So GitHub gets you the version control, but like Query will get you the API and a few other things, and the issue queues specifically around the data set, things like that. So I'll show. Yeah, this isn't one that actually made the list of responses, but it is something that a user had asked for in our Discord. And as you know, the turnstile data for New York City subway has been extremely popular. And extremely valuable to people. But this user asked for whether the same data was available for city bikes. So as far as I was aware, the answer was no. So last Friday, we actually made the data set. And before I show the data set, I'll show sort of what it looks like in the wild when you get the raw data from city bike. So let me share my screen. And let's do, give me just a moment, Google Chrome. So I'm going to search for NYC City Bike data. So City Bike publishes, this system data link is what we want. And then they've got downloadable files of City Bike trip data is this first one. So this is actually like raw data for individual trips. And this is what you end up at, is this index of a S3 bucket. And you can see each one of these is a zipped file for each month of data. And going back to 2013, so the latest one would be, right here. I found out actually from one of my students that this JC prefix stands for Jersey City because I guess they count them separately from the other part of the system. Or I guess technically it's a separate system. But you can see that those are much smaller. The New York City ones are quite large. So for 2020, we're looking at 101 megabytes zipped. And then inside this data set, let's see if I can download it and not crash my computer. You have a row for each trip, and it includes like the start time and the end time. We'll see if trying to open this live is going to be a bad decision. Unzipping, and let me open this. And hold on, I'm going to stop sharing my Chrome browser and start sharing. Oh, it can't be open right now. My computer's out of space. Lovely. Okay. Anyway, they're quite big. And I think the task at hand was just, okay, I don't care about the individual trips. I just want like an aggregate of daily ridership for each city bike station. And ridership to us just means entries and exits. So I wrote a simple R script last Friday just to see if I could get this up and running quickly. So the resulting data set is this one called City Bike Daily Counts 2020. It's under the NYC Transit Data user because it seems to be kind of analogous to the subway turnstile data. We have a link to the R script, but this is basically all it looks like. So you can see we've got a date column. So this is all January 1st. So there should be one record for January 1st for every station. In the system, we've got a lat long, so you can map it. And then start count and end count. This is basically just how many trips started from that station on that day and how many trips ended. So pretty simple aggregation, and then rejoining, aggregating and summing up the number of starts and ends, and then also rejoining it back with the like station name and latitude and longitude, so it's a little more human friendly and mappable. So that's a thing now. Got a couple downloads, and it's been up for a few days, but hopefully it'll gain some popularity if people are interested in this kind of transit data, or in transportation data. So let's take a look over here at, this is the tweet that we were talking about from last Friday. I'm in search of data sets, CSVs that live in Git repositories, but could benefit from living in query. The value adds would be structured metadata, add addition of column types that you can't store with a CSV, etc. So these are the ideas people came up with. So Aidan Feldman says, assorted data from the GSA, and sent a link. J. Albert Bowden II, which is he's also a new query user, was recommending CMS COVID nursing home data. And he's also working on that in Dataset, which is an awesome project. More COVID data from Aidan Feldman. This person, Simon W., is actually the person that made Dataset and has his own sort of collection of CSVs. So I think all of these would be wonderful candidates, but they're probably already in a good place, so he could bring them into Dataset, which is also useful. And yeah, good response here about a bunch that are maintained by Pigeon, not Pigeon, Pudding, and a lot of other sort of journalism repos. So, a lot of data journalists have to collect data first, and they'll share it as its own separate repository, or as its own separate collection in support of whatever the journalism project is that they're actually putting out. So 538, BuzzFeed, etc. All are good candidates there. And, this person was, assuming that we were backed by Git and GitHub, which we are not, and was kind of intrigued at the way we've set things up. So anyway, lots of good chatter there. I want to go through some of this list and continue to find good examples that are, puttable on query and not without a huge amount of effort, and see if there's any value, to these folks in having these published in a different place.
This is fantastic. The GSA data is really interesting right out the gates. I'm just looking at that GitHub repo right now.
Home for miscellaneous data published by the General Services Administration. Yep.
Miscellaneous data. Okay.
Yeah. And the term archive.gov domains. Yeah. So if you ever needed a list of
all the .govs.
Federal level .gov domains, this is it. Oh, fascinating. Amtrak OIG.gov. I didn't know that was a thing.
6,351 full .gov domains. That's more than I expected.
Oh, that's the entire top level domain? Sounds like.
Apparently, yeah.
Interesting. Very interesting.
Cool.
Yeah, this is a lovely set of things. And so, like, Chris, some of the stuff you were chatting a little bit on Discord about some of the ways that we could improve the sort of like number of steps that go between published data set and between like, hey, I want to make this file into a data set on query and something that's like published and ready and useful. Do you think walking through the I'd love to just know like how your time went when it came to the city bike project, because it's something you actually pulled off. And if you could walk through like was the main problem the R stuff, like, and like where, just getting a high level overview of how that process went together for you.
I'd say I spent most of, probably 80% of the time was actually writing the code. Here we can go. Not that we should be looking at the actual code, but it's pretty simple R script. So I've got a function here called process month, and it does what you would expect. You give it a month worth of data, and it will aggregate it and spit out basically like I then pass in every month starting in January. So I only have the 2020 data here. So I just have a little R list of months or month codes, and then each one of these is now part of a file name for the original CSV file, which was stored in a temp directory. So then I iterate over those and then spit out the aggregation and then stack them all on top of each other and then spit out the data set. So this just took a bunch of like, just like any other coding, just kind of trial and error and getting it to put out what I thought it should put out, and quality control on the output, and then rejoining it back with the lat long and stuff like that. So once I have that in a good place, then I'm like, oh, I'm done. But that's when the real work begins. So I think my commentary last week was just like, man, it just takes a long time to get these things published. So getting the data set is only step one. And I think the lazy or sort of simpler solution to that is just put it on the internet, and has no context, and it could be on an FTP server somewhere, it could be on GitHub, but at the very least it needs a README. So what I do is I'll drag it into Query Desktop. I'll start writing up a README, and generally speaking, the top of the README is always the same as the title and description fields in the meta. So I start with the title as like a H1 tag in the README, and then I have a few sentences with what this data set's all about, which are basically the description. Let's go back and look at what that looks like. Yeah, so I just say, a data set of aggregated station level city bike trip starts and ends for the year 2020. This stuff takes time. You got to think about how to describe this, and you write it and then you delete it and say that's too confusing. Add in a few hyperlinks. So I definitely want to link back to where the data came from as raw data. I want to link to the code, and I think this becomes problematic because I'm still finishing up the code. So this ends up in a repo called data story scripts. So I can kind of preemptively know what the URL will be. So I'll add that to the README here before I've even pushed the code to GitHub. So that's kind of like a duplicate sort of chicken and egg thing, is that I don't want to publish the query data set before the code is published, but I don't want to publish the code before the query data set is published. Anyway, so I usually just write this link before the repo even, or before that folder in the repo even exists. And then I also want to go do some like simple visualization. So I'll go to like something like data wrapper. And I think this is what we were after from the very beginning anyway, is like we've been looking at this 2020 turnstile data graph every single week going for, since COVID hit in March. We want to see kind of the same thing for city bike trips, and here it is. So this is like most of this work was driving towards like this specific chart. I want to see like what this looks like. And we can see that like, there was a hit in March and April, but it came back, really fast. I don't really know if I haven't compared this to the previous year, so I don't know if this is out of the ordinary traffic or normal traffic. But, you can see the blip that happened in April and May kind of goes away. So anyway, so that's another time-consuming part of it. Not terribly time-consuming, but export some data, bring it into Data Wrapper or some other visualization tool, and then promoting it a little bit, which is put this on Twitter, with a link to the data set as published on Query Cloud, and this visual kind of, which I just do with a screenshot. So it's all these little steps to kind of get everything in place. Part that I'm missing is like actually taking the screenshot and embedding it into the README of the data set, which, in order to do that, I need to host it somewhere first. So the hack I've been using is to like drag it into a GitHub issue and then copy the link and then paste it in there, which I don't know if that's kosher or not, but it works. And it's a way to do that. It's a way to get the image hosted quickly so I can share it inside this README. Anyway, that's a lot, but that's kind of a big overview of the steps.
Yeah, it's interesting, like how much when you're doing data, you have all your code responsibilities, which is all of GitHub, and then you have all of your data set versioning responsibilities, and then you have presentational, like product creation responsibilities. So like it's closer, like it's basically what we would do with like deploying, right? Like it's not like it's totally like the graph is deploying the data set in a way, or I guess that's also the publish on query, but there's a lot of, I think there's like room for improvement. The one link I'd love to quickly look at is this monthly trip raw trip data. And if we could look at the raw HTML of this page, just out of
this
curiosity.
page or the actual
this exact page. Yeah. The raw HTML of this exact page. Can actually, yeah, this will work. And go up to the head. I just want to see what the meta, this is like mainly script, meta. Is there anything interesting? Oh, yeah, okay. So that's Open Graph data.
Yep.
Because part of what I'm looking at is like in your process, if we go back to your query cloud data set.
Yep.
Your meta section is empty, right?
Right. You're saying there's a bunch of stuff we could automatically pull.
I'm wondering if that's worth it, right? Like if we could instead encourage a workflow that says, hey, you're trying to get, the problem with S3 buckets is they're quite devoid, right? Like this in this case, but you do have like a link. Could we have a list of like citation links that we encourage users to provide and then automatically pull Open Graph data from those?
Yeah.
The problem with automatic is it's like, hey, how many websites actually are going to have that stuff? And then you have to be careful with what link you choose. And then query needs some way to know how to prioritize one link or not over another, right? Because the body download link in this case is, just using this as an example, is an S3 bucket, which is not going to give us any cool Open Graph data. But the City Bike actual web page itself, can we actually look at that? Can we go back to that? I just want to see if it would have been any good if we had gone to all this effort. So we go to the head.
Where's head? Okay, here we are. No, head. Boop. And
okay, City Bike system data, City Bike NYC description, can find download. Yeah, like this is all really good, right? Property and image, Twitter card definition, like. This is all the stuff that everyone is really being encouraged to do because it makes their social media links look pretty and useful. And like pulling that down as part of our meta section would be quite valuable if we could find a nice heuristic for like, hey, go get the meta from this URL type thing. I don't know.
Yeah, I mean, I could totally see that being a, well, I don't know. I could see that being like in desktop, like a smart, like a smart thing.
Yeah.
Paste in a URL and it'll just say thinking, and then, I found this and this and this. Do you want to slide these values in somewhere, and you can just click on them and they'll become your description or become your, I don't know, just a thought.
Yeah, the user could use could eye it over before committing.
Yeah, that would be so much better.
Something Chris said before that I was thinking about relatedly is like when you start to write a README, it could just auto-populate with some fields from Meta if they exist already. Just like small little nice things can make a few steps a little bit shorter.
Yeah, for sure. I'm definitely like copying and pasting those. Either I started in Meta and I copy and paste them over to the README, or I started in README and I copy and paste them over to Meta. Depending.
Yeah.
Right. The key question is, where can we avoid copy and pasting using smart heuristics?
Exactly. And I think the wins here are like really helpful because this stuff is such drudgery, right? Like writing your meta section, it's like if you go through Chris's user's journey here, it was find data, find how to get data, write a whole bunch of code. Okay, and like at that point, Chris, I'm assuming you're doing this in one sitting and you're relatively tired by the time you've actually gotten the code to execute. You're just like, all right, okay, let's go. And it's that moment where that's where we're going to catch most people trying to publish data is like at the very end of a workday going, okay, time to hit publish. And like anything we can do to provide these magic moments, I think would be really great.
Yeah. I mean, it feels like, it's documentation, right? It feels like, and part of the developer flow is when you're done, you're finished, the thing works. And then you're just like, man, now my other task begins of like, I have, at the very least, have to like write up some words that, in a pull request that explain what the heck this code does, or even more, have to like actually write up a documentation page or something a little more detailed that's going to last longer than the pull request process. And yeah, it's just something you have to like budget time for. And I think most people don't. And that's why you end up with just orphaned CSVs lying around in places on your desktop or on the web. So like it's already a higher level of effort to like take action to not just have this data, but to share it. And then on top of that, sharing it properly is just more work. But yeah, it's like, I don't know, it kind of drives home that like, this is a publishing process, and this is not something you should do totally casually. Like, if you're doing it, there's a base level of doing it right.
Totally. Really interesting. Fun. Thank you. This is really helpful. I think there's lots of opportunities to like improve this process, make it a little easier. And that list that you presented from Twitter is like a great starting point.
I want to share actually real quick. I stumbled across this one today, which is also on GitHub, but it was on Reddit. And yeah, U.S. politicians Twitter data set, which has just got like the Twitter handles of all these different U.S. Politicians, which is interesting. And I'm like, this should be on Query. So this is another example of like, I think we talked about, writing a script that could, if you point it to a specific file in a specific Git repo, it can, it can basically just pull it down and check its version history and like actually make query commits for each change.
Do we want to try it right now?
Yeah, maybe something we want to work on. But anyway, wanted to share this one because it caught my eye this morning. That's all.
That's fantastic. Rico, if you want to chat about your data set, because I think this is a fun political segue, I will try and
Sure.
pop up a demo of this import.
There's actually a good query segue too, because my data set, which I'll show you, is one that I put plenty of work into, but then spent the time writing and coming up with a nice viz, and then republished the data on Query. And then I was like, all right, cool. I'm going to show people how I came up with these calculations in the README. And I was like, all right, I'm going to do that eventually. Like, that's what makes the data valuable for anybody who's coming to seek it. It's like, well, where'd you get this 17% number? But for background, I took it upon myself to kind of dig into some just basic US population stats by state to kind of get a estimate for how disparate different states are in terms of their representation in the Senate, which I have to acknowledge it every time I talk about this, that I acknowledge was never the point of the Senate. The Senate was supposed to have equal representation among the states, not among the people. But I think a lot of people, including myself, didn't know exactly how out of whack the population disparities were among the states. So I kind of took this on as a homework assignment. And share my screen to show you just a little bit about the journey and the output. So here's sort of a little experience using Query Cloud feedback. When I search Electoral College, this may come off as ego, but my result is the 6th one, even though the keywords that I use are exactly in the title of that data set, and I'm kind of curious. Maybe some tweaks to our algorithm might benefit from that. But this is how I've been digging around to find the link, which also is, maybe it's the way my screen is really the way it is, but I kind of prefer to do the searching for it than to go through my own admin profile. But here's the data set itself, and basically all I did was take cities and their 2019 estimated populations, and did a very easy calculation of how many senators they have. In the blog in which I write about it, I basically explained that what I did was took an average of, if our country has 320 million people in it, then a perfectly proportional Senate would have one senator out of 100 representing 3.2 million people. So if that's the baseline perfectly proportional representation, how far off are other states? And so I think the most interesting viz to come out of this is this first one. Uh-oh. Long time for Medium to go down. Which basically shows, if states are at the 100% line, that means that they've got 2 senators for 6.4 million people. So they're a pretty proportional state. So that probably applies to states like Tennessee, Indiana, Missouri, Maryland, Wisconsin, Colorado, Minnesota. California is famously our most populated, and Wyoming and Vermont are least populated. So in the table above, I basically give the stats for each of those states. So how much power do you have relative to what you would have in a proportional system? Famous example of California is the least advantaged at 17% of what they'd have in a proportional system, and Wyoming at 1,132%, which basically means they've got 11 times the power. And this is a very simple, just take each state's population and divide it by 2, and this is kind of the price they pay for each of their senators. So it's kind of similar data presented a different way. So, who's paying the most for their senators? Another interesting fact is our first 9 states here account for half of the US population. So 50% of our population is represented by just 18% of senators. And I tried to make this not very much a political argument in terms of like partisan politics. Texas voters get screwed over by, well, they don't get screwed over by Vermont, but compared to Vermont, a blue state, pretty disadvantaged. But the most famous example is California versus Wyoming, which is another blue versus red. But you can kind of see that there's no real obvious pattern here. Not just that, say extended delegation is not a great way of explaining whether something is whether a state is red or blue. It just explains who won that election somewhere between 2 and 6 years ago, or 0 and 4 years ago. Yeah, so I put the data here up on query. And I also wanted to kind of invite other analyses. So if the whole point of this was to sort of, compare the population size, which was not the design of the Senate, a lot of other fun ways to cut the data are, how much is each state contributing via GDP for how much senators it gets, which is kind of a dark way of looking at it. But, age distribution, population density, there's a lot of things you can do with the data set that I published with just some basic population stats.
That's fantastic.
Yeah, so I'll link to both those articles in the description.
So same question to you, Rick. You mentioned at the top that you sort of like ran out of steam for presenting your methodology, and you're planning on doing that in the README. How did you take notes on your methodology while you're prepping the data set? Or is it just like so simple to you that it's sort of...
Yeah, it's all in my head. And this was pretty simple work that if I had to redo it for somebody, it's just a couple of calculations. I think the other benefit is like, the methodology is in my Excel formulas, like take this cell, divide it by that cell. It's like, all right, cool. So this is what I was doing. Then going to account for it in the README. For this particular example is not hard, but you could imagine it being like complicated and not wanting to do it. If I were to vote for, I think in almost every README I've ever built, the access URL for the data that I'm building off of is something that I almost always cite, which we make prominent in the metadata, but I almost always feel like deserves another spot in the README. So I'd vote for that as like a possible default.
Yeah, and I think that really hints at what Dustin was getting at earlier of these heuristics for going between meta and README. One being generate a template README from meta, and then another being that exactly what you just said. Chris, in his example, actually had a link to a citation URL in the README, and as did you, and you sort of agree that it should be. It's basically the README is often saying, "Hey, like the general template we have for a lot of READMEs on GitHub is, hey, I'm starting from data whose source is here, right? Unless you are the person who is principally collecting the information, you have to cite your source, and that tends to be the first sentence of your README, like, hey, starting at this URL, I did X. Does that track?
Yeah.
And so if that's the case, then I think, as Dustin was saying, like being able to build a heuristic for that, I think a simple mechanism that checks the first link, this is super simple heuristic, the first link cited in a README for metadata information, I think is a pretty good guess of like, do you want us to guess a bunch of meta from this? And like add that, as you just said, it's usually a citation URL as well. And I know that from talking to you, you actually fill it in Query Desktop as like a cited URL in your meta section, which could be really useful. Chris?
I was also going to say that I think, the way that we show metadata on Query, the way we show meta on Query Cloud is just very simple, simplistic sort of table view. And it's probably not clear to people, but like the title in your meta actually becomes like the title of the data set and will show up in the unfurling cards on Twitter and stuff. And the description is also important. And those aren't really called out as like meta.description and meta.title as they live on. I actually do think there would be some value in, I mean, we kind of did this in desktop sort of, where we have like our preferred metadata or, the query, whatever we call it, where we've sort of
standard metadata.
Yeah, standard metadata versus custom metadata. It would be interesting to like make that distinction a little clearer, to just sort of nudge people to say like your data is not really complete, and like for any reasonable person publishing data, you should be able to fill out at least you should definitely have a title and description. You can most people will probably be able to link back to some other sort of sourcing document or sourcing page or something like that. And just not to call you out, but to just kind of just be like, hey, this isn't this isn't first class data until you've filled out all these things. And we can do that with user interface in cloud and desktop. So just a thought.
Totally. I think this is really interesting. Yeah. I'm wondering, I totally agree that we should be making standard metadata more prominent. I think that speaks to a larger question around like, and particularly on cloud, like how meta is kind of buried under this like thing, but we've really struggled with like, we use metadata, the actual contents of meta, to populate a cleaner template, but it's, as you said, Chris, it's not completely obvious where the source of that information is. That tends to derive from people just like kicking tires and using query and understanding, oh, if I set the title, it makes the title of the page look pretty.
Something I was thinking about with regards to that question of the meta not being filled out is like a kind of completeness rating or measurement or something. Like a lot of just apps have like, here's a checklist to fill out the rest of your profile. And it can include things like the meta, but also like, validation passing and things like that. And it would be a nice kind of like UI trainer just to like push users into like the expected steps, just, while they're learning it.
Yeah, we've actually made some inroads on coding this up, if I recall correctly, Dustin. I think in the like DS completion. Yeah, we actually are starting to build a numeric score index for that, and some things that maybe needs more attention. But
cool. Yeah, I mean the way it's surfaced in the UI is like the real key, because that's going to be
exactly.
It's training wheels in a lot of way.
Yeah, totally.
And it could also have links to like parts of the UI to click in order to like fill things out. So it's not just like here's how far you are. It's like click this to fill in the title.
Yes, totally. And like that might be a great place for this like UI. Give us a citation URL widget. Cool. Quickly, I can close the loop on that import thing, just to like get this into the public record. So, Chris, as you did mention, hopefully everyone's seeing a shared screen of this. What is this? US politicians Twitter data set. Cool. So I'm going to go like this. I'm going to copy this. And so as Chris had been mentioning, we've been working on a Git importer for query. So I'm going to clone this locally. Cool. And now if I cd US, I should make this bigger, shouldn't I? Is that better? Hopefully.
Oh, this is totally rad. I had no idea that this already existed. So live demo, just because I mentioned it, sounds really awesome.
Awesome. I'm glad to hear it. Here's US politicians Twitter data set. So we've got dataset.csv. This is like very much a work in progress tool. Like ideally we'll finish the first pass. This is sprint, but if I do query git, and then I'm going to do US politicians on Twitter is going to be the name of the data set. And then I'm going to say dataset.csv should be the file that I use. And so when I hit enter on this, it'll do, okay, there were 3 commits that contain changes to that body file. And if I do query get me US politicians on Twitter, you can see a whole bunch of data, and we also get the schema that was inferred, and a bunch of other bits, which is fun. Yeah, and that's actually working. And then if we do query log, same thing. You can actually see, no, I need query log this. You can see all the commits added and aligned. The reasons we have work to do here, the most important one is this importer doesn't do any citation. And so I would not publish this right now because this doesn't properly cite the original source. And in this case, I think it should be citing the actual Git hashes in the metadata itself. And it doesn't yet adjust the timestamps. So I won't publish this, but this is coming. If you want to see the code for this, it is available on github.com/query-git. And this will where we'll do all the importer and maybe eventually exporting tools. But yeah, this is fun coming along. It's working quite nicely so far. But should be possible to import and retain history. Just to talk through what this does under the hood, this doesn't just walk every commit. This actually figures out which commits change the file that you mentioned, and it tracks changes to the file name itself. And so if the name changed from dataset to original data.csv, it'll try and walk through that and pull that history out. Yeah. So I think it's a nice place to sort of like end the discussion on better inference of meta, doing more stuff automatically, and really trying to leverage as many heuristics as possible and having these like optimistic try-ins or optimistic best efforts that we take. I think we've gotten a lot of mileage out of the schema inference inquiry, and now what's coming with the new stats automatic calculation, where we just do this stuff for you. You give us data, we give you back the schema and stats. I think if you give us links and we give you back metadata, and if you give us metadata, we give you back a template README. Those things are good starting points at a pretty crucial moment in the process. Chris and Rika, you both illustrated this, I think, in spades. I do it all the time where like I finish a data set and then I get to the meta part and I'm just so tired, and because it's usually in one setting. I'm just like, okay, anything query can do there would be really helpful. So neat. Anyone want to have a last word?
No, I would just say, this is in the chat, Asmer just saying, search needs some love. We got a lot of data sets now, and I think that's totally true. Searching and browsing, you know, I see the same featured data sets, and then if you're not in the last like 7 published, then I've got to hope to search for you. So I think in the coming weeks and months, we should visit. I know I'm preaching to the choir, preaching to the preachers.
No, very much agree. I think the point that you're making, Asmer, is this is the first time that our search indexes need actual tuning. So you're sort of getting at. Yeah. And so it's like now we actually have to start paying more attention to stuff and changing our search indexes based on more useful information. And so we'll start to do that, which is fun. Cool. All right. Well, I think that's as good a place as any to end it. We've got some fun ideas for future features. Next call will be on Friday, and hopefully we will be, I think we will be, at bare minimum, we'll have a release candidate out for next Friday, or for this coming Friday, to like, on the back end, to sort of start to look through and understand. This will include a bunch of massive performance improvements, as I mentioned, automatic stats calculation and storage, which will be the basis for change reports, which is the feature that we're all working on very hard right now. So looking forward to that.
This is cool stuff. Exciting.
Woohoo!
These are exciting times in our lives, kind of.
Awesome. Well, thanks so much, everybody.
Cool.
See you Friday.